Hi, how's it going? I'm going to show some features of the different languages that are supported by Beckhoff and IEC 61131. The previous video I did a ladder instance of a motor coil or a motor starter with just a start button, stop button, and the coil. I'm going to go ahead and create some other POUs here, and we're going to take a look at what that looks like. That shouldn't be under POUs. So we're going to go ahead and start, and I'm going to create a new POU here. I'm just going to right click on POUs, add new item. Um, I'm not going to get into function blocks or functions yet. Those each really need to be their own video. So we're going to call this something. I'll just call it, which language should we do first? Let's do function block diagram next. Let's do function block diagram POU. And of course we need to change it to function block diagram and click open. That's unusual. Alright, that was odd. Function block diagram looks a whole lot like ladder. It looks a little bit too much like ladder, actually. Oh no, it is function block diagram. It uses the same code. Twincat uses the same code to render ladder and function block diagram for the most part. They're really similar in functionality and the way they work. If you're used to ladder, function block diagram is really not that much different. It's very similar. So in ladder, man, what is it doing that for? Let me do a restart here quick. Okay, so where was I at? So ladder looks really similar to function block diagram. The main difference is that in ladder for Boolean logic you have contacts and coils, but you can also in ladder you can have function blocks in here. So like let me log out. It won't let me change when I'm online. Let's right click, insert network below, and we'll throw in just a countdown. We can see it looks just like a function block because it pretty much is a function block. Um, we can go ahead and delete that. If we go into function block diagram, really the biggest difference is in the Boolean operators like the ands and the ors. Obviously in ladder, this is if an or and an and, so ors are in parallel, ands are in series. Function block diagram is just organized a little bit differently. So let's do our same motor starter example here in function block diagram and see what that looks like. So I'm going to go in here and I'm just going to copy these three variables. Actually, I'm going to clean these up really quick. That's going to bother the crap out of me. So if I just do tab. If you watched the previous video, you would know that I created these with a table view. I am used to looking at the text view, so it's just personal preference. If you look at the table view, it'll be just fine. Need to capitalize. I like humpback notation. Just personal preference. And I also like to tab everything nice and neat so that it all lines up. We'll put a space there. Alright, so we got our three variables here. I'm just going to copy and paste these over into our other POU. So these are local tags. They're not global. They're only usable in the program that they're declared in. I'll get into how to create global variable lists and work with those a little bit later. It's really no more difficult than any other PLC platform. It's just that it's not really necessary for this video. So to create a motor starter circuit, we've got our Boolean operators up here. We've got the ands and the ors. So really, if we kind of look at the way this works, we've got that we need our button stop to be false. If somebody presses the button stop, we can't have our coil on. So if the button stop is false and the coil is on or the start button is pressed, then our coil is on. So we're going to kind of think that same way. I'm going to drop an and in here, and the output of this and is going to be our coil. Um, let's see here, insert assignment, and we'll just copy and paste our coil. So we need this stop button to be false for our coil to be on. If the stop button is true, that means somebody's pressing the stop button, and we do not want that motor to run. So I'm going to copy the stop button, and I'm going to paste it into this first and here. And then I'm going to right click on this line right next to it and click negation. So that's going to mean that this input to the and is true whenever this variable is false. So it just inverts it. If the variable is true, it makes it false. If the variable is false, it makes it true. Um, so that's our stop button there, and that's going to work just fine. That's all we need to do for that. The next kind of thing in our ladder is the or. We have a if the coil is on or the button is start, or the button start is being pressed, we want our coil to come on. So I'm just going to drop in an or block here, right there. We just kind of drop that on, and it'll automatically link up with our block. And we can right click and append inputs all day long. We can have as many inputs as here as we want. Same thing with the and. We can keep appending inputs for as many as we need on that function block. And you can kind of right click on the base of the input there and delete it. Delete the ones that you don't need. Not all function blocks do this. It's mainly just the core ones, like the ands and the ors, and there may be some of the math ones or something, like the adds, that you can do that with. So now we're going to put in our coil again. So if our coil is on, or our start button, is being pressed, we want to turn our coil on. So that's it. That should work. Let's go ahead and log in. Oh wait, I forgot one thing. One really important thing, and that's that we need to call this program. Right now there's nothing in our PLC telling us to run this code. So I'm going to go over here to our main POU, and I'm just going to insert another network. And I believe I can do this. I usually don't do calls from ladder. I usually do them in structured text, so bear with me for a second here. Let me see. Insert. Is it in here? I'm just not sure where it's at. I might be able to drag and drop. No, some of them you can drag and drop. Other operators, math, function blocks, branch execute. It might be execute. Nope, that's structured text. Jump, insert, network, return. I'm not sure how to call another program from within ladder. Like I say, I never do it this way. I always have a structured text as my main program, and then I just call other programs that way. There's another way we can do this really easily. Right click on our main task, add existing item, and we can add our POU in this way, and it'll call it as well. Like I say, usually I only have one POU under here, but this will certainly work. And I don't believe I needed to activate there, but that'll certainly do. And wait just a second here. A lot of times it'll throw an error the first time I try to log in after an activate. This time we're good to go. And here we go. We've got our logic again. So first thing I'm going to do, I'm going to press the start button, see if our motor starts, right? So let's double click on that. We can see it's going to write a true value in there. Come up here and click the write values button. So right now our operator is pressing that button. Our operator releases the button, and we can see the motor still stays running. If we come in here and we want to stop the motor, we can double click on this and write the value to set that to true. And so now our operator is pressing the stop button, and now our operator released the stop button, and our coil turned back off. So that motor starter is good. Exact same functionality as this, it just looks a little bit different. It's just kind of another way of thinking about it. Thanks for your attention. That's been a really brief intro to function block diagram. Have fun coding.